I welcome you all, wonderful learners out here. Thank you for your support, for your love. So, today I'm going to start up with a new series wherein I'm only going to take the questions in the form of LAQs, right? So, we'll be learning, but then we'll be also learning how to write. So this is Dr. Reena's Physiology, Conceptual and Integrated. This is my Telegram channel or the Telegram group rather, Physiology Synapse to Success, wherein I provide you notes for whatever classes I take. So please ensure that you like, comment and subscribe the channel and share it so that physiology can be really made easy for one and many. Okay, so the question which I am going to discuss is related to renal physiology. And the question is related to one of the very important LAQ, that is question is on LAQ with GFR, where the total marks are 10 and which are divided in the following manner. Describe in detail with a neat well-labeled diagram that is showing the glomerular filtration rate under the following headings. So once it is under the following headings, it becomes very easy how to write the answer. The forces, which are of around 3 marks, factors affecting 2 marks, regulation 3 marks and measurement 2 marks. So let us start discussing. Now whenever you are starting an answer, see, when you write an essay in school, yaad hai, how do you write? You are always tried or you are always asked by your teacher to make an intro before you start writing the body. So you can start your answer in the following manner, that there are 3 steps in urine formation: ultrafiltration through the renal corpuscle, that is through the glomerular capillaries into the Bowman space, there is reabsorption and there is secretion. So these are the 3 steps which are involved in the urine formation. You can show this with the help of a diagram where you can see that I've taken a very simple diagram which is just showing the Bowman's capsule, the tuft of glomerular capillaries, the afferent arteriole and the efferent arteriole. This is the first process, that is the glomerular filtration. The second process, which is reabsorption, so anything which is to be reabsorbed will be taken into the capillaries, and the third step, which is secretion, so that anything which is not needed will be taken or will be secreted into the lumen, and finally it will be excreted in the urine. So as we know that the question is on GFR, so you need to define. GFR or the glomerular filtration rate is defined as the amount of filtrate formed by glomerular filtering membrane. There is a glomerular filtrating membrane by of both the kidneys in a unit time. The normal value is 125 ml per minute, that is 180 liters per day, which is also asked as an MCQ to you. So start your answer with definition and with introduction. Now, the glomerular filtration that is the first step of urine formation, whatever you formed is actually an ultrafiltrate of the plasma. Now this product is called as an ultrafiltrate. Whatever it is getting filtered through the filtering membrane or through the glomerular capillary filtering membrane is called as an ultrafiltrate because it contains all the constituents same as plasma except plasma proteins. So plasma में और जो हमारा अल्ट्रा फिल्ट्रेट है इसमें सब कुछ सेम है except the proteins which are present in the plasma is not present in the glomerular filtrate, right? You can add a line that this filtration membrane consists of 3 layers: fenestrated capillary endothelium, basement membrane and the podocytes or the filtration barrier, which is formed by the visceral layer of the Bowman's capsule. So this comes up with your introduction. Now coming to the factors affecting and regulation. Now this is a very easy diagram which you can easily draw to explain the GFR. Now we know that when we speak of GFR, GFR is nothing but it is KF into NFP. This KF is nothing but it is called as the filtration coefficient. Okay, so it is the filtration coefficient. And NFP, these are the net filtration pressures or the net filtration forces. right? Net filtration pressure or the net filtration forces. These are actually called as the Starling forces. So whenever you are, coming across the word Starling, remember these are the Starling forces which are acting at the level of the glomerular capillaries, pulmonary capillaries and systemic capillaries. And they are of two types: hydrostatic pressures which are given by P and colloid osmotic pressures which are given by pi. A very simple way of remembering, P hydrostatic is a pushing force. So जहाँ पर भी ये force ज़्यादा होगा, it will push. Whereas the colloid osmotics are the colloidal osmotic forces. They are called as the pulling forces. So you can just remember this, pushing and pulling. So this will make it very, very simple. So these hydrostatic and the colloid osmotic pressures will be present here at the glomerular capillaries and at the Bowman's capsule. Now you know that the proteins are never filtered from the glomerular capillaries into the Bowman space. I told you it is an ultrafiltrate and there is a barrier of the filtration membrane, so the proteins are never filtered. So actually this pi, that is the colloid osmotic pressure of the Bowman's capsule, is 0. So this force is actually not a physiological force which is existing unless and until proteins are present in the Bowman's capsule, which is totally pathological. There should never be any proteins, कोई भी proteins will never come from the glomerular capillaries into the Bowman space. It is never seen. So this force, that is colloidal osmotic pressure at the Bowman's capsule, is normally 0, which is not physiologically in action. So the net filtration pressure is glomerular hydrostatic pressure minus Bowman's capsule hydrostatic pressure minus glomerular capillary hydrostatic pressure, which is 60 minus 18 minus 32. So the net filtration pressure comes to be 10 mmHg. That means these are the forces which are going to govern or which are going to regulate your GFR. Now, the GFR is governed by the pressure gradients, or these Starling forces which we have discussed are the hydrostatic and the osmotic, and the filtration coefficient which we gave as Kf. This Kf is also called as your hydraulic conductivity. Hydraulic conductivity means it is totally dependent upon the product of the glomerular capillary permeability and the effective filtration surface area. So it depends upon the permeability of the capillaries, it depends upon the surface area of the capillaries or this effective surface area. If these two factors are affected, filtration coefficient will be decreased. And if the filtration coefficient, that is the Kf, is decreased, there will be decrease in GFR, right? So these are the four forces, the net filtration pressures and the filtration coefficient, which are making the equation of GFR, which you are supposed to write. Now, this was the question, that what are the factors affecting GFR. This can itself come as an SAQ to you, 5 marks SAQ, सिर्फ ये आ सकता है. Now, I am not asking you the conditions. If I am asking you the conditions affecting GFR, so be very, very specific. I am not asking you the conditions affecting GFR. Conditions agar bola, then you will have to write conditions like exercise, pregnancy, posture, age. These all, they come as your posture, age. These all, they come as condition. But what the question is, factors affecting GFR. So these important factors are, which are affecting GFR: the change in the renal blood flow, glomerular capillary hydrostatic pressure, change in the capsular hydrostatic pressure, that is the Bowman's capsule hydrostatic pressure, the oncotic pressure, that is the glomerular capillary oncotic or the colloidal osmotic pressure, the glomerular capillary permeability, and the effective filtration surface area. These two are the components of your Kf, that is filtration coefficient. Then the size, the shape and the electrical charge of the molecule that is to be filtered. So these are the factors which are affecting GFR. So Kf is hydraulic conductivity into surface area, that is the permeability into surface area. And the conditions which decrease the GFR, which decrease the Kf, will also decrease the GFR. Any condition where the glomerular capillary membrane is thickened which could be glomerulonephritis, obesity, diabetes, hypertension. These conditions, they result in nephropathy. So these nephropathies में the KF will be reduced and the GFR will be reduced. Now this we've seen. Okay, the second important force is the force which is called as the hydrostatic pressure of the Bowman's capsule. Hydrostatic pressure of the Bowman's capsule. Now the hydrostatic pressure of the Bowman's capsule, P for hydrostatic pressure, B for Bowman's capsule. It is a backward pressure. Normally this pressure is also not physiologically needed. Okay, it is not a force that is physiologically governing the GFR, because it is a back pressure which will be raised only when there are conditions. For example, there is urinary tract obstruction like benign hypertrophy of prostate, or there is tubular obstruction which occurs mainly when there are renal stones, kidney stones, or the calculi which we say in the ureter or the bladder, which increase the back pressure. So this is pathological, this is not physiological. So normally the hydrostatic pressure of the Bowman's capsule is maintained, which will not affect the GFR unless and until it is pathologically affected. Okay, so we've seen the KF, filtration coefficient, we've seen the hydrostatic pressure of the Bowman's capsule. Now the next one is the colloidal osmotic pressure of the glomerular capillaries. Now if this colloidal osmotic pressure of the glomerular capillaries increases, just see over here, what will happen? यहाँ पर देखो, अगर यहाँ आपने बहुत सारे proteins add कर दिए, if you keep on adding up proteins in the glomerular capillaries, the colloidal osmotic pressure of the glomerular capillaries will increase. I have told you that the glomerular capillary or the colloidal osmotic pressures, these are pulling pressures. So what will they do? They will cause pulling. That means in this manner, opposite direction. That means from the Bowman's capsule towards the glomerular capillaries. Okay, from the Bowman's capsule towards the glomerular capillaries will be the flow. That means this is an opposing force. Okay, this is an opposing force, and therefore if there is an increase in the glomerular capillary colloidal osmotic pressure, there will be a decrease in the GFR. For example, if there is an increase in the plasma proteins, okay, if any condition there is an increase in the plasma proteins, more proteins will come to get filtered in the capillaries, and the pi g will increase and the GFR will decrease. Also, if there is a decrease in the renal plasma flow, right, if there is a decrease in the renal plasma flow, that will also result in the accumulation of the proteins, and again the pi g will increase, which will decrease the GFR, right? So hydrostatic pressure of the Bowman's capsule, colloidal osmotic pressure of the glomerular capillaries. Now the most major determinant of GFR and which is most subjected to physiological control is the hydrostatic pressure of the glomerular capillaries. Hydrostatic pressure of the glomerular capillaries. So P for hydrostatic pressure, GC for the glomerular capillaries. This is the most physiological factor which is subjected to control. So the conditions which can affect this pressure are arterial pressure, that is your mean arterial blood pressure, afferent arteriolar resistance, and the efferent arteriolar resistance, right? So if there is an increase in the mean blood pressure, okay, that is the arterial pressure, there will be increase in the hydrostatic pressure of the glomerular capillaries, and there will be an increase in GFR. If there is afferent arteriolar dilatation, there will be increase in the glomerular capillary hydrostatic pressure, which will increase your GFR. The efferent arterioles show dual effect. Mild resistance, okay, mild efferent arteriolar resistance increases GFR, but if there is a severe efferent arteriolar resistance, it will decrease GFR. So remember, the most important physiological determinant is your hydrostatic pressure of the glomerular capillaries, which is subjected to control. For example, when there is sympathetic stimulation, pressure increases, the mean arterial blood pressure increases, the GFR will decrease. This is the reason that why in exercise the blood flow to the kidney is decreased, the GFR is decreased, and the sympathetics, they are taking the blood to the vital organs. Now, among other factors, so first we've considered the hydraulic conductivity, that is Kf. Then we looked over the three forces: the glomerular capillary hydrostatic pressure, Bowman's capsule hydrostatic pressure, and the glomerular capillaries colloidal osmotic pressure. And because the proteins are filtered, the Bowman's capsule colloidal osmotic pressure is 0, which is not under consideration. So the other factors which can affect our GFR include the changes in the renal blood flow. If there is an increase in the renal blood flow, that means if there is renal vasodilatation, there is going to be increase in the delivery of the blood to the glomerulus, and that will promote or that will increase GFR. So if the renal blood flow increases, there will be increase in the GFR. Now the size, the shape, and the electrical charge of the macromolecules. So remember, the particles, especially positive, that is cationic, because the glomerular membrane has got negative charges. So cationic, that is positive particles which have got molecular weight less than 10,000, molecular weight less than, not more than, just make it correct, molecular weight less than 10,000, or the size is between 6 to 8 nanometers in diameter, which can freely pass through the filtration barrier. And remember, the slender molecules, they can pass more easily than the spherical. So 6 to 8 nanometer spherical cationic are the particles which are going to be more favored. This you can remember. Right? So factors affecting, it is very, very clear now that if I get a question on factors affecting, what am I going to write? So factors affecting: change in the renal blood flow, glomerular capillary hydrostatic pressure, Bowman's capsule hydrostatic pressure, oncotic or the colloidal osmotic pressure, the filtration coefficient, that is the glomerular capillary permeability, effective filtration surface area, the size, shape, and the electrical charge of the molecules. The next part of the question was measurement of GFR. So remember, the measurement of GFR is based on the principle of renal clearance. Renal clearance itself is a 2 marks BAQ, which I have seen that is not written correctly. So what is renal clearance? It is the volume of plasma. And what do you write? Volume of substance. It is not the volume of substance. It is the volume of plasma from which a particular substance is completely cleared off per unit time. That means, suppose this is kidney. Okay, this is kidney, and you know that plasma is coming. How much is GFR? GFR is 180 liters per day. How much is your plasma? On an average, it is suppose 3 liters. That means this plasma is going to get filtered about 60 times per day. 180 divided by 3. 60 times per day, and therefore the filtrate is an ultrafiltrate. So every time when the plasma is going through the kidney, it is getting filtered, or the volume of that plasma is getting cleared of a particular substance. If you don't want that substance, it will be cleared. That means it will be excreted in urine, right? So glucose is never, we say that the clearance of glucose is 0. The clearance of glucose is 0 because glucose is never cleared, isn't it? Glucose is never cleared. There is 100% reabsorption of glucose. So understand the definition. It is the volume of plasma that is getting cleared per unit time, right? It is given by the formula Cx, where Cx is the clearance, which is Ux divided by Px into V multiplied by V, where Ux is the concentration of the substance in urine, Px is the concentration of substance in plasma multiplied by V, that is the urine flow rate. So this also comes in your NEET PG for calculation. As far as the substance which is taken for the glomerular filtration rate is inulin. Because inulin is a substance that is neither reabsorbed nor secreted, right? It is not stored in the body, it is not altered, it is neither reabsorbed nor formed nor secreted. It is only filtered, it is only filtered. It is not disturbing any other thing in the body because it is not even metabolized. Therefore the inulin clearance is equal to that of GFR, which is 125 ml per minute. However, practically instead of inulin, what is preferred is creatinine, because creatinine is the end product of creatine phosphate, which is a skeletal muscle derivative. It is continuously produced in the body, excreted, so practically it is used, right? So when you are using creatinine, there is no need of exogenously giving some substance to calculate GFR. It is already present in the body, right? However, because it is secreted, the GFR with creatinine is going to be 140 ml per minute, not 125, because it is secreted, right? Now, the regulation of GFR, this was the next part of the question. This includes various neural mechanisms, hormonal mechanisms, myogenic, and the tubular-glomerular feedback mechanisms. So these are the four main headings which you will have to write. You can just write in 1 or 2 sentences to complete so that your answer becomes proper. Sometimes the time management has to be done. So in neural mechanism, you will be having to write sympathetic stimulation. So activation of the sympathetic system or the sympathetic fibers, they cause constriction of the afferent arteriole. This is going to decrease the blood flow to the glomerulus or the glomerular capillaries, and this is going to decrease GFR. And whenever there is sympathetic stimulation, let it be emotions, pain, fear, or I just told you exercise, there is going to be decrease in GFR. Then there are various hormones which affect GFR. For example, angiotensin 2, it causes constriction of the afferent and the efferent arteriole, but its effect on the afferent arteriole is more than on the efferent arteriole, and therefore angiotensin 2 decreases the GFR. Then dopamine is a vasodilator and it increases GFR. Atrial natriuretic peptide increases GFR. It is also a vasodilator and it will be secreted from the body, that is especially from the heart, whenever there is an increase in the blood volume. Because if you remember, you might have studied, it causes what we called as natriuresis, that is loss of sodium from the urine or through the urine, loss or excretion of sodium, and diuresis, that is excretion of water. The another important thing is nitric oxide, which is also called as the endothelial derived relaxation factor, which increases GFR. Then there is bradykinin, which increases GFR, and there is PGE2, that is prostaglandin E2, which causes relaxation of the mesangial cells and also increase GFR. So neural mechanisms, then you have got hormonal mechanisms. Now tubular-glomerular feedback mechanism itself is a short note which you can get. So this is this is working at the level of macula densa. That means it is working at the level of DCT. So you can just take it in the form of a flow chart, which is easy to remember also. Decrease in the arterial pressure decreases the glomerular capillary hydrostatic pressure. We've seen that there is a direct relationship which will decrease GFR. If the GFR decreases, then the amount of sodium chloride which is entering into the macula densa decreases. This is going to decrease the afferent arteriolar resistance. That means at the level of the afferent arterioles, you are going to get dilatation. Okay, you're going to get dilatation. Whenever there is a decrease in the NaCl coming in the macula densa will convey this signal to the juxtaglomerular cells. The juxtaglomerular cells in turn will secrete renin. This will activate the renin-angiotensin mechanism. Angiotensin 2 is going to cause increase in the afferent arteriolar resistance, and we know that the mild efferent arteriolar resistance increases GFR. So this is the tubular-glomerular feedback mechanism which is working at the level of macula densa, that is your DCT, which should be mentioned with regulation. This is very important. The second important is myogenic theory, which can also be taken in the form of a flow chart. What does this theory say? Is that whenever there is increase in the arterial pressure, there is going to be a stretch of the blood vessels. You know that these blood vessels are actually made up of the smooth muscle cells. So these stretch and the resultant opening of the calcium channels. There is an increase in the intracellular calcium, which is actually going to cause the smooth muscle contraction. So when the smooth muscle contraction is there, that means the diameter will decrease. There will be vasoconstriction, isn't it? So this is suppose the blood vessel, and this is the smooth muscle cells. So you're going to contract it. As you contract it, the lumen will decrease. That means vasoconstriction. Whenever there is vasoconstriction, there is increase in the resistance, and whenever there is an increase in the resistance, the blood flow and the GFR will decrease. Okay, so this myogenic mechanism is very important, that even if the blood pressure increases, the blood flow and the GFR will never increase. They will be maintained through this myogenic mechanism. So please remember that as much as possible, draw flow charts. Learn in the form of the flow charts. It is very appealing for the examiner also. And finally, you can just conclude your answer that like there is auto-regulation of the renal blood flow, the GFR is also auto-regulated. The auto-regulation of the GFR maintains a constant rate of filtration. That means despite of changes in the systemic arterial pressure in the range of 80 to 180, the GFR will be maintained. That means if the mean systemic blood pressure, which is normally 90, if it decreases to 80 or if it increases to 180, still also the renal blood flow and the GFR, okay, this is the renal blood flow and the GFR, they are well maintained. They are not increased or decreased. This is called as auto-regulation. So this is all for this lecture. If you really think that the lecture is useful, please ensure that you like and comment, because appreciation is a part of a learning process of humanity. So do appreciate a teacher's effort by just a like and a comment. Subscribe the channel, come on to the group so that we can have the free notes which are available over here. Thank you all and God bless you.